Okie dokie, let's try this one. Now we get interesting. RQ is something that's not so prominent. I actually think it's off the syllabus now in Unit 4 at OCR. But they've brought it in by telling you about it. Some animals conserve energy by entering a state of torpor, short period of dormancy, in which they allow their temperature to fall below normal for a number of hours. In an investigation of torpor in the Siberian hamster, Phoropus sungarus, the animal's respiratory quotient RQ was measured before and during the period of torpor. Respiratory quotient is determined by the following equation. RQ values for different respiratory substrates have been determined as shown in table 1.1. Alright, this used to be on the syllabus, so I know what's important about this, and the important thing about RQ is working out what the organism is using for energy. So down here, and what colour are we at? Let me get my pencil on and let's go for, and I think we still remain at red. So let's have a look. So what I know is that under RQ, this here, a carbohydrate will have an RQ of 1, lipid or fats 0.7, proteins 0.9. Initially the RQ value determined for the hamster was 0.95. Alright, so if I look at this 0.95, I kind of get the question, and I think it's going to be about what this hamster is burning during torpor. So it starts at 0.95, but as the period of torpor progressed, its RQ decreased to 0.75. What do these values suggest about the substrates? So here we've got the substrates, carb, lipid and protein, respired by the hamster during the investigation. Okay, so let's look at the first thing we can say is that it changes, and it does change. So substrate itself, and it's an easy mark, the substrate changes. We have to say from what yet. Well, so substrate changes over the period, over the time of this investigation. Now, if we look at the 0.95 initially, we can say that initially it's carbohydrates. Okay, maybe a little something else. Maybe a little protein, maybe a little bit of lipid, but mostly carbohydrates is very close to 1. And what I then say is we look at it and it goes to 0.75. If it goes to 0.75, then what we've started to do is no longer we're using a lot of carbohydrates as it gets to 0.75 over time, starting to use lipids, and there has to be some protein. There must be some protein, maybe even a little carb, a little carbohydrates. But that's what it tells us. And the interesting thing, and what we know about this, and if we think about what this organism's doing, it initially uses carbohydrates, and as it runs out of carbohydrates, it then starts using lipids. Protein is going to be a last resort because it's going to start damaging itself. It wants to use its energy stored of carbohydrates, then lipids. And there you go, another one done.